A very good morning to one and all. Myself, Dr. Veena Benakatti. I am working as a reader in Department of Prosthodontics at KALABURAGI Institute of Dental Sciences, Belgium. So I am given the task of covering the topic that is biostatistics. So let us start with this statement. When you can measure what you are speaking about and express it in numbers, you know something about it. But when you cannot express it in numbers, your knowledge is of meager and unsatisfactory kind. So what is statistics? Statistics is a science which deals with collection, classification and tabulation of numerical facts as the basis for explaining, describing and comparing certain phenomena. So now what is biostatistics? It is branch of statistics which is applied to, which includes statistical methods applied to biological and health related data, so which focuses on collecting, analyzing and interpreting health related data from living organisms so that we can understand health, disease and the biological processes. So now what are the functions of statistics? So the statistic will present the facts in a definite format. It simplifies a large mass of figures and it will also facilitate to compare two variables. Also, it helps in formulating hypothesis and formulation of policies. So the statistics will give you a crucial guidance in determining what information is reliable, which predictions can be trusted. So that it helps in solving a scientific mystery and also it prevents investigators from being misled by false impressions. Now there are also some limitation of statistics. Unlike physical sciences, that statistical laws are only approximations. They are not exact. They provide conclusions and decisions based on probability, not certainty. Hence, statistical conclusions are not universally true, but they are true on an average. So now let us understand certain terminologies. Datum, so which means the information which is stated as figure. For example, a bite force of a single patient which is 250 newtons is a datum. Data, which is plural form of datum, stated in more than one figure. For example, bite force values of 50 patients measured in a study. So this data is a collective recording of observations either in a numerical format or otherwise. As we can see in this picture, the weight has been presented in a table format. So this is the data presentation. So now we can conclude that statistics is a science of collecting, presenting, summarizing, analyzing and interpreting the data. So now let us come to what are the different types of data. Qualitative and quantitative. So what is quantitative data? This is expressed in numbers that can be measured or counted with some unit of measurement. For example, height, age, bite force or flexural strength of dental materials. These can be expressed in quantity or measurements. Now what is qualitative data? Data representing a quality or attribute which is expressed as categories but they cannot be measured in numbers. For example, religion, sex, patient satisfaction, etc. So based on the sources of data, data can be classified as primary data and secondary data. So what is primary data? Which is directly obtained by the investigators. The primary data is new and original. For example, we collect information through surveys, interviews and experiments. That becomes primary data. So secondary data is obtained from other sources like already existing information from government data or hospital records, journal articles or websites. When you obtain data from sources like this, it becomes a secondary data. So now what are the measurement scales for these data? First is nominal and ordinal scale. So what is nominal scale? So as it suggests, it is the names or labels which are used to record or name this data. So categories are not ordered. For example, eye color could be blue, brown or green, which is different. It could be race, sex. So these indicate a qualitative data. So now what is ordinal data and how it is different from nominal? So this is also used for qualitative data or for labeling the categories, but however they are ordered. Like if you can see in the picture, it is poor, fair, good, excellent. So this is an order. Another example could be ranking of students, first, second, third, and for example, another patient satisfaction, which can be classified as poor, fair, good, and excellent. Now coming to another measurement scale, that is ratio scale and interval scale. Interval scale has an equal intervals, but it does not start from 0 or does not have a true 0. So values are always in numbers. For example, body temperature and student's IQ. Now what is ratio scale? It is also similar to interval scale. It has all the characteristics of interval scale, but it also has a true 0. So now coming to sampling. So what is sampling? Sampling involves selecting a number of units from a defined population. So there are two types of sampling techniques. One is probability sampling and non-probability sampling. So what is probability sampling? So the sample is selected by random. That means every unit in the population has equal chance of being selected. In non-probability, there is no randomization. That means each unit in the population do not have an equal chance to be included in the study. So under probability, we have different sampling techniques, that is simple random, systematic random, cluster, stratified random, multi-stage and multi-phase. As we can see in this picture, so out of a population, we are randomly selecting certain units. Now under non-probability sampling, we have convenience sampling, purposive sampling, snowball sampling and quota sampling. So as we can see in this picture, so only those who are dressed in black are purposely chosen for your study. This is purposive sampling. So let us see each sampling technique. So simple random. So here the selection of unit is only by chance. So this is useful when you have a small homogeneous and readily available population. Okay, so then how do you ensure randomness in this? You can go for either a lottery method or a table of random. Let's see an example. So suppose you have to choose 10 patients out of 100 patients and put them on a trial. Now what you have to do is shuffle all the cards, draw one card out, then reshuffle again, draw the second card, continue to draw 10 samples. So up to 10 samples you draw. So this becomes your simple random sampling technique. So now what is systematic random sampling? So this is used when you already have a complete list of population available. So this is used in field studies. So this how this works: selecting one unit by random and then selecting additional units at evenly spaced intervals. Again, let's see with an example. You need to recruit 20 patients and put them on a trial out of 200 patients. So you have to calculate that like this: 200 by 20, which is 10, and then you choose a random number from 1 to 10. Let's say 6. So then you have to add 6 to every 10, like 10 plus 6, 16, then 26, 36, and so on. So now you are going to examine or include a unit that is every 10th house after 6th house. So for this example, for studying the influenza in Bombay, so this method was adapted. Now coming to stratified sampling. As the name suggests, the target population is divided into homogeneous groups, or we can call it as classes or strata. For example, these classes, groups or strata could be based on age, sex, geographical area, etc. Now coming to next technique, that is cluster sampling. So it is a randomly selected group. So here units of population are naturally in groups. For example, like villages, talukas, wards, blocks and factories. So these clusters already exist. So from these you will randomly select the population for your study. Now coming to multi-stage sampling. So sampling in several stages using a random sampling technique. So it is employed in large surveys. Let's see an example. So for hookworm survey in districts, you will choose 10% villages in talukas and examine all persons in every 10th house. Now coming to what is multi-phase sampling. So sometimes it is not possible to collect all information at one phase. So then you will collect information at more phases, one or more phases, which is useful for identifying a specific disease. So let's see with an example. So in tuberculosis survey, Montague's test is done in all cases in the first phase, and then in the second phase you will take an chest X-ray, and which you had already done for your Montague's, only for the Montague's positive cases. And then again in third phase you will do a sputum examination where there is X-ray positive cases. So now coming to errors in sampling. There could be two types of errors, that is sampling errors and non-sampling errors. So sampling errors can happen due to faulty sample design or faulty sample techniques and a very smaller sample size. So how can you address this error? By choosing a correct sampling technique and also by increasing the sample size. So there is another sampling error which is known as non-sampling error, which covers coverage error, observational error and processing error. So this happens during your data collection or at any stage of data collection. So to overcome these non-sampling errors, so a proper training has to be given to the investigators or the people who are collecting the data. So this will include a quality control. So we can avoid by this the non-sampling errors. Now coming to the important topic, that is sample size. So for our thesis, we all do a sample size calculation. We are always apprehensive about what sample size will come for our thesis. So now why is it important? The importance of sample size is, if you take a very small or too small sample size, so your study will be underpowered and you might miss the real effect. If you take a too large sample size, it could be waste of time and resources. So the goal here is to have an adequate sample size, okay, with adequate power, which is usually 80%, so that if you can detect a meaningful effect if at all it is present. The sample should be big enough to have a higher likelihood of detecting a difference between groups. So now calculating this sample size is affected by several factors. As we can see here, the first could be, that is study objective, based on what type of study you are undertaking, that is descriptive, comparative or analytical. And then again it will depend on type of data, whether it is qualitative or quantitative, and also the accepted effect size, that is how strong or meaningful a relationship or difference is. And then variability in population, which is calculated by using standard deviation, then level of significance, power of study. So these all factors will affect your sample size. So the most important is type 1, type 2 error and effect size. So these will determine how much your sample size is going to be for your research. So each statistical test has its own sample size formula. So it is important to decide the main study variable and the statistical test you are going to use for your research. So based on this, you will choose the sample size formula. So now how do you identify these all? Previously I mentioned these all values which will determine your sample size. So where do you find all these values? So you can find these values from either the previous published studies, or you can perform a palette study and calculate. If at all both are not there, you don't have any published literature or you are also not conducted palette study, then you can go for a conservative or a assumptive approach. Apart from this, then next you also have to consider the drop rate in a study. So there usually you can consider 10 to 20% drop rates. So as the effect size increases, the power of the test increases. So but the sample size also decreases. Conversely, if the effect size is small, the sample size must increase in order to detect that small difference significantly. Effect size is obtained from means like standard deviations, proportions, so provided in previous studies or from the pilot studies. So now there are certain softwares which can help you do the sample size calculations. Like we have, so you have to give all the inputs as I mentioned previously, the factors affecting. So if you give these inputs into this software, it will calculate the sample size. This, for example, you have a G power, which is the most commonly used software for calculating the sample size. And then you have a OpenEpi, and then you have a WHO sample size calculator. So we have studied what are the factors that affect the sample size, and we have also considered many softwares and all. So but however, it is highly recommended that consulting a professional statistician for the sample size is recommended, as it involves several factors and sometimes be complex. So it has to be confirmed with a professional statistician. So let's see some of the formulas. Suppose if you want to compare two means, example, you want to measure the difference in plaque scores between two groups, group A and group B. Another example could be you want to compare the marginal bone loss between two different implant systems. So you are going to use this formula displayed here. So now if you want to estimate a single mean, example, finding the average salivary flow rate in a patient, then you are going to use the given formula. So if you are comparing two proportions, that is comparing the proportion of successful implants with two different techniques, then you are going to go for this formula. So as I mentioned, so based on your study objectives and what you are comparing, so you are going to choose your sample size formulas. Now these were for the quantitative data. Now for qualitative data, what sample size formula you will use? So this is the sample size formula which you will use for qualitative data. For example, proportion of denture wearers satisfied with new impression material. For such studies, you can go for this formula. So now how you are going to do the sample size calculation? So as I mentioned, literature, so previously published studies, the most preferred, the pilot study if literature is not available, and then go for conservative approach assumption if nothing is available. So now coming to the next topic, that is presentation of data. So you have conducted your research and you have collected the data. Now how you are going to present this data? So you have to present it without losing the details. It should also arise interest in the readers, and it should make a very simple, concise, meaningful and helpful presentation of the data. So what are the different methods of presenting this data? So one is tabulation and another could be diagrams and drawings. So coming to the tabulation, that is presenting the data in the form of tables. So here large number of observations are presented concisely, giving the entire information at a glance. There are certain rules if you are going for tabulation, that each table should contain the title of the table number 1, 2 like this, and it has to have a heading for the table, rows, columns should be clear and concise, the class interval should be of an equal width, and the unit of measurement should be specified. Suppose if you are calculating age, years or months, weight, kgs like that. And then source of data should be mentioned and group should be tabulated in order. Now let us see with an example. So this is a simple table which just speaks about the number of patients reporting to your college in different months like Jan, Feb, March. So this is a frequency distribution table where it speaks about the frequency. Like patients with 0 to 3 cavities were 78 in number, while patients with 3 to 6 cavities were 67 in number, 6 to 9, 32, and 9 and above 16. This is how you are going to present the information in the table format. So apart from these tables, you can also give a visual representation of your data. Let's see how you can do it. So for quantitative continuous measure data, you can go for histogram, frequency polygon, frequency curve, line chart, cumulative frequency diagram, scatter or dot diagram. If you have a qualitative data, then you can present it in bar diagram, pie sector, pictogram and map diagram. So let's start with histogram. So it is a pictorial presentation of frequency distribution. So as you can see in this picture, it has a continuous series of rectangles. So class interval is given here on the vertical axis. The x-axis has an, as we can see in this table, let's take example from this table which we previously saw, that is number of cavities and the number of patients. So in the x-axis you are going to take number of carious lesions, and in the y-axis you are going to take the class interval. So now these rectangles will speak about the frequencies. So this area of the rectangle is proportional to the frequency. Like for 0 to 3, you have 75 patients. For 3 to 6, you have 45 patients. This is how histogram is presented. So this gives a clear visualization of your data at one glance. So let's take another example, that is distribution of dental implants placed to restore single missing teeth. So here in the x-axis we have the tooth numbers, that is 1, 6, 2, 5, 2, 6, 3, 6, etc. And this is the number of implants or the frequency. Okay, as we can see, 4, 6 is the most commonly replaced tooth with the implants, followed by 3, 6. So coming to the next one, frequency polygon. So the frequency polygon is obtained by joining the midpoints of the histogram blocks at the height of the frequency by a straight line like this, which will then form a polygon known as frequency polygon. So this will tell you about the trend of the how frequencies are changing. Now coming to frequency curve. So when the number of observations is very huge and the class intervals are smaller, then the frequency polygon will take a shape of frequency curve. So what is this frequency curve? It is a smooth continuous curve drawn by joining the midpoints of class intervals that represent the data distribution. So this frequency curve will illustrate how the frequencies are distributed across different values and is used to visualize the pattern of or shape of data distribution. So basically we have to understand, so this will tell you how the data is distributed over the different variables. So coming to the next, that is line diagram. So this is the simplest way to represent the data. As we can see in this examples, it will tell you, it will represent how the trends are changing over time, whether it is rising, falling, or showing any fluctuations. So here let's see this example. So here we have a year and here we have a prevalence of caries. So during the initial year there is a slightly rise in the caries. So however it is coming down over the years, almost coming to negligible. So this is how your line diagram will tell you about the trend over the years. Now let us take one more example, that is the patients coming with the periodontitis. So this is the number of years and this is the number of patients. As we can see, over the years the number of patients coming with periodontitis is raising. This is how a line diagram helps to visualize your data. So here another example is, here you have a follow-up of implant patients in terms of months, and here you have this implant survival rate. As you can see, so initial months the implant survival is higher, so slightly it comes down and then it is stable over other months. So coming to bar diagram, a bar diagram represents data using rectangular bars where the length and height of the bar shows the magnitude or frequency for this variable. So it is the most popular and easy method. So it will give a visual comparison of different frequencies. So it should be drawn either in ascending or descending order, or the magnitude, and in a serial order of events. So let's see with example. Here you can see number of patients. So the number of CD patients. So in the first quarter, so 250 was the number of CD patients, while in second quarter we have somewhere around 150 to 200. So on third and fourth quarter. So this is the most simplest format of presenting your data. So this, I have another example for bar diagram. So this speaks about the comparison of luting cements in different degrees of tapers with respect to tensile strength. Now here we have cements along with the taper. This is zinc phosphate with 6-degree taper, zinc phosphate with 12-degree taper, same way GIC with 6-degree taper, 12-degree, and again we have a resin cement with different tapers, and this is your tensile strength. So now we can read clearly from this radiograph that resin cement with 6-degree taper has the highest tensile strength and the lowest is for the zinc phosphate with 24-degree taper. So this is another example. So now coming to the next, that is multiple bar graph. So how this works? A multiple bar diagram is used to compare two or more related variables under the same category. So each category has a set of bars which are equal in width placed adjacent to each other. So this is especially useful for qualitative data. So, and these bars are color coded or shaded to represent different variables. Now you can see, now we are going to see how many CD, RPD and FPD patients are coming in each quarter. So if you see in the first quarter, this has three components, that is CD, RPD and FPD. So this is the number of CD patients, this is RPD, and then you have a FPD patients under different quarters. So here you are representing more variables of the same category in the bar format. Now coming to component bar diagram. A component bar diagram is used to represent both number of cases in a major group and distribution within its subgroups. Now if you want to see the patients coming to prostho and patient coming to other departments. So in the first quarter, the other departments you have 1500 patients visiting, but in the same quarter there are 300 patients visiting the prostho department, and so on for the second, third, fourth quarters. So next is your pie diagram. A pie diagram represents data as sectors of circle, where the entire circle is the 100%, or you can say total frequency, while each sector is proportional to the percentage of frequency for that category. So this shows a proportionate contribution of each category to the total. So now you can see here prostho we have 200 patients, which includes 31% of the total patients visiting the college, and cons we have 24% of the total patients visiting the college, that is around 150, and so forth for the next. So then we have a This is cartograms are also known as spot maps, which is used to show geographical distribution of frequencies of a character. Here directly it will show the where the frequencies are like the geographic location, it will show the different countries. So now coming to the important topic, that is measures of location. So what is measure of location? The measure of location, also known as measures of central tendency, will describe the position of center or typical value in a complete data set. That is, it will tell you where the most data values lie along the scale. So it will locate the data central or a typical point. So under this we have measures of central tendency and measures of dispersion. So under measures of central tendency we have mean, median, mode, and for dispersion we have range, variance and standard deviation. So now let us start with measures of central tendency. Here entire mass of data is summarized in a single value or a single estimate of a series of data. As the name suggests, it will summarize all of your data into one single value. So the average value is a distribution, is the central value around which your all other observations are accumulated. So how does this help? It helps you to find the most characteristic value of your set of data, and it also tell you which group is better off by comparing the average of the mean of one group with the mean of the other group. The commonly used averages for your measures of central tendency are mean, median and mode. Now mean, so it refers to arithmetic mean, and this is the formula, that is sum of all the observations of the data divided by number of observations. So one disadvantage of this is it is affected by the extreme values. Now let us see with an example. So here is the 0 to 10 is your data collected. So you all add all of them and then divide by the number. So you get mean is equal to 5. So here you have the data distributed along the scale like this. You add all of them and then divide it by number of observations, then it is the 6. So this is the most commonly used measure of central tendency to represent or your data. So now let's see, this is one example where you have tabulated the data in this table format. That is group A, JIC which is a control group. You are measuring the tensile strength here. So this is the tensile strength. All these values are tensile strength under these groups. Group A GIC control, Group B resin modified GIC, Group C resin modified GIC with surface treatment. Then you have a resin cement and resin cement with surface treatment. So now I have recorded all these 10 readings here. Now in this we are going to take a mean of all these 10 records. Group A, the mean is going to be 3.78. Group B1, so and you have like this. Now you can easily compare between the groups. You can see the mean tensile strength of group C2 is the highest. Now coming to median. When all the observations are arranged either in ascending or descending order, the middle observation is known as the median. So in case of even number, the average value is average of the two middle values is taken. So it is the one advantage of this is like mean, it is not affected by extreme values. Now if you can see your data along this scale, so the in between the median would be your 5. So before you choose a median, you have to arrange it in either ascending or descending order. So here you have an even number, so you have to add your middle two observations and then take an average of that. Now again let's see the median with an example. So DMFT of 7 children is 7, this is the number. So you arranged it in order, that is increasing order, and then you identify the middle point, that is your median is 5. Well, you have an even number here, so you take two middle points, 6 plus 7, so the average is your 6.5. Coming to mode, as the name suggests, it is the most frequently occurring observation in your data set. It is not affected by extreme values. It can be used in numerical or categorical data. So there could be several modes, or there could be one mode, two mode, there could be no mode. So here we can see, again it is arranged here. So we can see which is the most frequently occurring number or a data in this. Okay, so mode here is 9. While here we have no mode, there could be no mode. So now if we summarize all this measure of central tendency, so mean, so data without extreme, it is best when you don't have a extreme values. As we saw, if there are extreme values, so mean becomes more sensitive. So for example, average age of patients is 35 years who are visiting to your maybe clinic. So median, so when the data is skewed, you have a outliers, so you can go for a median. Example could be median income of patients is 40,000, which is less affected by few or a high incomes. Coming to the mode, to find the most frequent value or category, the most common tooth replaced is your 3-6. So geometric mean, it is used for ratios, percentage or growth rates, that is average bacterial reduction rates across time. And for harmonic mean, example is your average rate of implant placement. So now coming to measures of variation. So biological data collected always show variation from each other. Suppose if you take a BP of an individual, okay, even if you take by standardized method, okay, and also taken by the same person and you repeat it over time, so it will show variation. Another example could be a freeway space is given in the range of 2 to 4 m, that it varies between 2 and 4 mm. So thus one should know what is the normal variation and how do you measure it. So now what are the various measures of variation? That is range, mean or average deviation, standard deviation and coefficient of variation. Now let's see what is range. So it is a difference between the highest and the lowest figures in a sample. So what does it do? It defines the normal limits of biological characteristics. For example, like freeway space. What is the range? That is, the minimum could be 2 and maximum could be 4. So is it satisfactory? Not really. Sometimes this is based on only two extreme values. So coming to mean deviation. So mean deviation will show you how much the values in a data set differ from an average or from the central value. That is, what is your mean and how your other values are surrounded, or how much difference is there between the mean and the other values in a data set. It gives an absolute difference from the central value, and this is a formula for calculating the mean deviation. Now coming to standard deviation. So under this is standard deviation means it is root mean square deviation. So it is a summary measure of differences of each observations from mean of all observations. So greater the standard deviation, greater will be the magnitude or dispersion from the mean. So smaller the standard deviation, the more uniform all the observations are. That means if you have a higher standard deviation, then your all data in a data set vary from the mean. If lesser the standard deviation, then there is a uniformity of all the observations. Now coming to how do you use this standard deviation. First, it helps summarizing the deviation, that is, it measures how spread out the data is from the mean of a large distribution. So if this is the mean, how data is distributed around this mean. So this is given by your standard deviation. Then it will also help us in determining the sample size. How does it affect? Greater the standard deviation, you will have to go for a larger sample size so that you can draw meaningful conclusions. Now it also helps calculate the standard error. It helps determine if the difference between two samples is real or it is just by chance. So let us see with example. Here if you see your data, all the data whatever you have collected are very similar to each other. So your mean is 7, hence your standard deviation is 0. That is, there is not much deviation between all sets of data. So here you have a two different numbers. So your standard deviation is 0.63, okay, which is slightly less. Now you have all the data are completely different from each other in your data set. So that means your standard deviation is going to be very high. So in such cases, you will have to go for a larger sample size so that you can check if there is any real effect. Now coming to frequency distribution or normal curve. A normal distribution, which is also known as Gaussian distribution, is a type of probability distribution. So it is symmetrical, bell-shaped, and most values cluster around the mean. So for example, usually the height of adults, the IQ scores, or always have a normal distribution. These are the general examples which usually have a normal distribution. So the normal distribution is significant because it models the real world data. So now let's see how is a normal curve. It is bilaterally symmetrical, that is right and left sides are mirror images. So if this is your bilaterally symmetrical bell-shaped normal curve, if you see from the center, so this is a mirror image of this side. So the right and left are mirror images of each other. So frequency increases from one side from one side and reaches the highest, and then same way it comes down the way it has increased. So the highest point, if you see this point, the highest point is denotes the where mean, median and mode coincide or they are equal. So it is well shaped where most data points are near the mean. In this data distribution, you can see the most of the data is clustered around the mean. So extremes are rare. So now coming to another important topic, that is probability or chance. What is it? So it is defined as a relative frequency or a probable chances of occurrence with which an event is expected to occur on an average. So let us see with example, probability of success. If a surgeon succeeds in 80 cases out of 100 cases, then what is your probability? So number of success divided by total number operated. So your probability of success is 0.8. While if you see probability of failure, that is 20 out of 100 cases, that means your probability of success is 0.8 while your probability of failure is 0.2. So this p-value is helps us to assess the dissimilarity between two sets of measurements. So p-value is a probability that a difference is due to chance. That means if your probability value is lesser, that is less than 0.05, then your results are significant. Means your results are not just by chance, there is a real difference. If at all, if it is more than 0.05, it suggests there could be the results could be by chance. So that's why we always calculate the p-value, which should be less than 0.05 so that your results are significant. So p-value tells us how likely the observed results are due to random chance or if they are really significant. A small p-value that is lesser than 0.05 suggests the results are unlikely to be random. So the effect or difference is real. So smaller the p-value, higher the significance of your results. So how can you calculate this p-value? It is calculated using a test statistic and its probability distribution using these softwares, that is SPSS, R or Excel. Now coming to test of significance, another important topic. So even well selected samples may differ slightly from the main population or from each other, which can result in a variation in the results. So the differences in results between two research workers who are working for the same research, by the same investigator, you can also find some differences. So therefore you need to test the statistical significance of your findings. So you have to find out whether your results are due to just chance or some real biological variation is there. That means your results are statistically not significant. So, or if it is due to influence of some actual external factor which is affecting and causing a difference, that means your results are statistically significant. So to test this statistically significant results, so you have a different tests. They're classified as parametric and non-parametric. So parametric will assume the data distribution is normal, which we previously studied, that if your data is normal distribution, then you go for parametric test. And if you assume that it is not under normal distribution or a non-normal data, then you have to go for a non-parametric test. So now let's see what are these different tests. So under parametric, we have student t-test, which could be paired or unpaired. And then you have a ANOVA, Pearson correlation regression analysis. Under non-parametric, you have a Mann-Whitney chi-square, Friedman test, sign test, Wilkinson test, and Spearman-Rank correlation. So what are the stages in performing these tests of significance? First is you have to state your null hypothesis. That is, there is no effect or no difference. That is, you are testing two drugs, drug A and drug B. Now your null hypothesis says that drug A is equal to drug B. Both are similar, there is no difference. So then you state the alternate hypothesis that your drug A is or drug B is better than your drug A. Then you will calculate the test statistic using your test significance, and then you will determine the p-value. So based on your this p-value, if it is less than 0.05, then you reject the null hypothesis and accept your alternate hypothesis, that is your results are significant. If your p-value goes more, then your results are not significant. You reject the alternate hypothesis and you accept the null hypothesis. Now coming to what are these tests of significance, let's start with unpaired t-test. As the name suggests, it is used to compare the means of two independent groups. Okay, so here we have a group A and group B. Group A has a children who are given normal diet, along with which they are also using given the supplements of vitamin A and vitamin D. While in group B, children are taking the normal usual diet. So the gain in weight in pounds for both the groups after 12 months is tabulated here. So you have to now check if vitamin A and D are really responsible for gain in weight. So now here you are going to again calculate the mean of group A, mean of group B, then you are going to calculate the standard deviation, standard error. So by these all formulas, now you will calculate the p value which is coming up to, that is less than 0.02. So which means your results are statistically significant, which means there is a role of vitamin A and D for the increase in weight. Now again coming to paired t-test. So here it is used to compare the means of two related groups or measurements to see if there is a significant difference. That is, these are used to test the two related groups. Now for example, systolic BP of a normal individual before and after injection of hypotensive drug. Okay, does the drug lower the BP? So now BP before giving the drug, this was the BP recorded. Now this is the BP recorded after the drug, and this is the what amount of difference is found in the BP before and after the drug. Now again you will calculate all the values, and now you are calculating the p value which is coming up to 0.001. That means your results are highly significant. That means the drug has effect, that is it causes decrease in the BP. That's how you come to conclusion. Now coming to ANOVA, that is analysis of variance. Investigators may not always be confined to compare only two groups. Okay, you might have to go for comparing the difference in vertical dimension. Maybe you might use three or more groups. Okay, like now let us take on dental example. So you want to check, compare the difference in vertical dimension obtained using three techniques or more than three techniques, that is phonetic swallowing or Niswonger methods. So in such cases where there are more than two samples or two groups, so you can go for ANOVA, which is used to compare the means of three or more groups. So also when measurements are influenced by several other factors, like factors affecting the retention of denture. So it simply means whenever you have more than two groups, then you go for ANOVA. Less than two groups, you can go for paid or unpaid. Two groups, you can go for paid or unpaid t-test. So again, under ANOVA, we have one-way ANOVA, two-way ANOVA, and multi-way ANOVA. So one-way ANOVA is suitable when one factor affects the result between two groups. So let us see with example. One way, so effect of three different toothpaste on plaque reduction. So for two-way ANOVA, effect of toothpaste type as well as brushing frequency on plaque retention. For multi-way ANOVA, studying the effect of crown material, three materials you have, the cement type, again you have these many cements, and then you want to check the marginal fit accuracy, while also you want to evaluate the how the effect of cement type varies with the crown material. So you have so many variables here. So in such way you can go for a multi-way ANOVA. So now just to summarize this test of significance. So if your data is normal and continuous and you want to compare two means, go for t-test, paid or unpaid, depending on the this thing. So then if your data is normal, continuous, but you want to compare more than three groups, go for ANOVA. Your data is normal and continuous, you want to measure relationship between two variables, then go for Pearson correlation. So your data is not normal or ordinal, then but still you want to compare two groups, then go for Mann-Whitney this test. So it is not normal or ordinal, you want to compare three groups, then go for Kruskal values. And then not normal or ordinal, you want to measure the relation between two variables, then go for Spearman correlation. So you have a categorical nominal ordinal data, so you want to test association between two variables, then you go for a chi-square test. So again, another summary, we can read it like this. If you want to compare two groups and you have continuous data, again go for a t-test or Mann-Whitney test. Compare more than two groups, go for ANOVA Kruskal Valley. You want to test association between two variables, go for chi-square or Fisher exact. And measure relationship between variables, but you have a continuous and ordinal data, then go for a Pearson correlation. So now coming to, so we all studied so much of statistics now. So how you are going to perform these procedures? There are several softwares for this analysis and research. So let us see. The first could be MS Excel, which it is a general one, so where you can organize your data nicely in the Excel. So you should always organize your data using the Excel. Then you have a SPSS, which is a comprehensive statistical software where you can perform all your significant tests, that is t-test, ANOVA, regression, chi-square, etc. Then you have another statistical software known as MedCalc. It is specially helpful for medical and dental specific tasks and ROC analysis. I myself have used this MedCalc. It is good. So for a medical and dental, you can go for this. So most of this is also we have a open source, that is free softwares. And then next we have a Stata, so which is used in epidemiology, public health and survey data. And then you have a Raven, which is a powerful open source, and it also requires the coding. So now this is for your statistical analysis. Now for your thesis and publications reference management, we have softwares like Zotero, Mendeley and EndNote. It will help you to organize your citations, generate your bibliography for your thesis and publications. Now coming to the study designs. So based on the timing, the study design could be prospective, which means you are going to follow the participants forward in time. It could be retrospective, that is you are going to look back at the existing data, or you are going to go back and see the data. Prospective example is cohort and clinical trial. For retrospective, it is case control and retrospective cohort. And then you have a cross-sectional studies, which we all perform the surveys. So here you are going to assess population at a single point of time. That is, you take a cross-section of a population and assess them at that particular time of study. So example is a prevalence study and your cross-sectional surveys. That is your KAP studies, knowledge, attitude, and perceptions. Now, based on the intervention, the study could be your experimental or observational. Experimental means you are going to, investigator is going to assign some kind of intervention to your participants, while in observational, he is only going to observe without any intervention. For experimental, the example is RCTs. For observational, you have cohort, case control, and cross-sectional. And then again, based on purpose, you have descriptive, where you are going to describe the disease occurrence. Case report, case series, and prevalence study. Analytical, where you are going to analyze or compare the different groups and you are going to analyze the risk factors like cohort, case control, and RCT. Now again, some other study designs, case report or series. So this has a detailed report on one or small patient group. So it helps us in understanding the new disease identification and rare condition documentation. Cross-sectional study, that is a snapshot of a population at one point of time, national health surveys, dental satisfaction surveys, and KAP surveys. So what is longitudinal study? So it is the observational study where the data is collected from the same subjects repeatedly over time to study what changes or trends are happening over the years. Example is your tracking the implant success rates or bone loss over several years. Case control study. So you are going to compare cases with that is with disease and then controls that is without disease. So it is helpful in investigating the rare diseases. In a cohort study, you are going to follow a group. Cohort means it is a group over the time to track the what are the outcomes. So in randomized control, this is a gold standard experimental study for any kind of research. So for new drug testing, for any surgical technique comparison, you are going to employ your RCTs. So systematic review and meta-analysis, it combines the results of already published, that is multiple studies. So it helps in clinical guideline development and evidence synthesis. So now let us summarize whatever statistics we have studied. First is your collection of data. Collect accurate and reliable data. And then you have to organize your data. Okay. So you can go for a tabulation or diagrams. Then presentation of data, diagrams, graphs or picture. And then you are going to analyze. Sometimes by simply putting them in a table, by simple observation you can analyze. Sometimes you will have to apply statistical techniques and then you have to interpret. That is, you have to draw conclusions based on your results. So now coming to when you are conducting any research, so what are the steps involved here? So first you have to define the problem. So how do you define the problem? Through your literature review, or also you will identify problems from your regular clinical practices. You can find out previous research graphs from the published studies. You can also talk to experts. They can also give you certain clue on the problem definition. So the patient complaints can give you an insight into problems. You can also go through health reports and policies, so you can identify the problem or your research topic. So next is to set aims and objectives. So go for SMART, that is your objective should be specific, measurable, achievable, relevant, and time bound. You have to define all this while you are defining your objective. Then plan of action includes designing your study, selecting the sample, rule outing all the errors, and recording of the data. Once your data is collected, you present it, then you statistically analyze it, and after analysis you draw the conclusions, and whatever is your findings, disseminate through your publications and conference presentations. So now in publications, so what is the format? First you have to decide the title of the article, and then you have to go for the abstract writing. This is the format for writing any publication or paper. Then introduction, then you have to add review of literature. In introduction you are just introducing to the topic, what is the importance of your topic which you have chosen. Then review of literature, so on whatever topic you have chosen, you have to see what literature is available and where are the gaps that can be spelled out under your review of literature. And then you have to present your materials and methods. So how you have to present your methods is, it should be able to be duplicated by another person who is reading your paper, so it should be accurately mentioned. Then you're going to mention your results, your analysis, and then you're going to write the discussion conclusion, and then you're going to give future recommendations. What were the limitations of your study and what are the opportunities in your study to go ahead with the further research, any acknowledgement, references, and then appendices. This is the format for writing your paper. Now I just went through some of the previous year question papers. So I found out some of these questions. You can just take a snapshot of this. So from these questions, I have just made out some notes. There was a question on prevalence and incidence. So prevalence means it is a total number of existing cases which include old plus new in a population at a given point of time. While incidence means it is a number of cases which are being added in the population over a specified period. So your prevalence is going to measure the burden of disease, while your incidence is going to tell you about the risk of developing the disease. Prevalence happens at a particular point or a particular period, while incidence happen over a defined time interval. So prevalence will tell you the percent of people currently having periodontitis at a certain point or period of time, while incidence will tell you the percent of people who are developing periodontitis over the year. Another question was on the confounder. So what is confounder? So it is a third variable that distorts the apparent relation between an exposure and an outcome, acting as a hidden factor which will influence both. Now let's see with an example. So the research question is, does implant surface type affect implant survival? Now the potential confounder here could be your bone quality or density, because that is also going to affect your implant survival. Now if you want to study only the implant surface, whether it is going to affect the survival or no, but also you have to consider other points like bone quality and density, so which might act as a confounder. So poor bone quality can lower the survival rates regardless of the surface type, giving a false impression that one surface is inferior and another is superior. So how do researchers control these confounders? Researchers control the confounders through study design methods like randomization and matching, or statistical adjustments during the analysis to ensure the observed association is true. So by modifying your study designs and other techniques, you can go for go for covering these confounders. So these are the references. So I thank you everyone for patient listening. I also thank you the organizing committee for giving me this opportunity. Thank you one and all.